So we are going to start looking at the theorems one after the other. Now, the secret of circle geometry is to look at the question carefully. And the first thing, you need to know all the theorems. I'm not saying you should cram it. Just know what the theorem is. Understand what the theorem is saying. Are you getting it now? So once you know the theorem, anytime you see question, you know that this question is going to satisfy this particular theorem. Do you get that now? So that is the first thing to look at. Note the theorem. Now, the first theorem we are going to look at is under chord property of a circle. Now, the theorem says that a straight line drawn from the center of a circle to the middle point of a chord, which is not diameter, is at right angle to that chord. So what do we mean by that? So you can see I'm saying it in another way, and we are saying the same thing. What I have on the board is a straight line drawn from the center of a circle to bisect a chord, which is not diameter, is at right angles to it. So it's the same way if you say a straight line drawn from the center of a circle to bisect a chord, which is not diameter, is at right angle to the chord. Or you say a straight line drawn from a center of a circle to the middle point of a chord, which is not diameter, is at what? Right angle to the chord. Do you get that now? So interpreting this theorem is what we are going to look at. Our circle can be, let's say this is our circle. This is the center of a circle. Don't forget, your chord can be anywhere. I can decide to have my chord here, so far it's touching 2 points on the circumference of a circle. You get that now? I can decide to have my own chord like this. I can decide to have my own chord like this. You get that now? You can see all these 3 chords I have here, they are not diameter. What do we mean by a chord that is a diameter? It is the one that passes through the center of the circle. You get that now? So if I have my circle, by that theorem, what do I mean by that? This is a circle. Let's say this is the center of a circle. Then I have a chord which is not a diameter. Let's say this is a chord which is not a diameter. And the theorem says a straight line is drawn from the center to the middle chord. Let's say this is straight line drawing. Now, from this, what I'm going to do little, is at right angle to the chord. I'm going to do little construction. My little construction, let's say this is the center of a circle, O. I'm going to join, let's say the chord is AB. I'm going to join OA and join OB. Do you get that now? So if nobody is going to ask us to prove, but if we are asked to prove, it's very straightforward. I draw a circle, I locate the center, I draw a chord, from that center a straight line to the middle point of the chord. Then I make a little construction. I join this to this, join this to this. So what is this I'm joining? OA, what does it mean? It means what? The radius. OB, it means radius. So I have 2 radius, and the plural form of radius is radii. So I have OA is equals to OB, and they are both radii. Are you getting it now? Both radius. The plural form is what? Radii. So that is what I have on the board. Now, this point here, I can decide to call it another letter. Let me call it M, for example. You can call it D, another letter apart from what you have on the board. So, on this theorem, it's saying that it's at right angle to the chord. Now, I know that this is radius, this is radius. Now, if you look at this, you can see I have 3 triangles, the big one and 2 right angles. Now, we want to show that this place. Now, if I had from here, like this, is a triangle. This is another triangle. Now, if I go by angle on a straight line, you know angle on a straight line is what? 180 degrees. So I can say the angle here, let me just say OMA. Are you getting it now? I can say OMA. When I put angle on M, it means I'm referring to this angle here. OMA plus OMB, that is, I'm referring to this angle here. OMB is what? 180 degrees. Reason, sum of angle on a straight line. On a straight line. So that's the reason, sum of angle on a straight line. So if this place OMA and OMB, they are equals to 180 degree. And as you can see from that diagram, it's telling me that OMA is the same thing as OMB. You can see the diagram is the same. So if they are the same, that means I can have this. If let's say this is A and this is the same thing as A, so you know A plus A, that is 2A. So that means I can have 2 of what? OMA to be equals to what? 180, because I said they are the same triangle. So if I divide both side by 2, my OMA is going to be 180 all over 2, and that gives me 90 degrees. So that shows that this angle here is what? 90 degree. 90 degree. So that shows that OMA is what? 90 degree. Do you get that now? So that's the analysis of the theorem. Are you getting my point? So we are going to pick question. Let's pick questions.